Today we're going to be looking at some calculation that has to do with Avogadro's law. You know, Avogadro's is the man that established the fact that gases at constant temperature and pressure, equal volume of gases at constant temperature and pressure, they have what? Equal volume, which finally is known as what? Molar volume of gases. So these few questions we have here has to do with this molar volume. So how do we reapply it in calculation? Because we say that at STP, every gas, equal volume of gas has what? The same number of particles, and also the volume remains what? The same. So let's look at the questions we have. The first question we have here says that what volume of oxygen is produced from the decomposition of 2 moles of potassium trioxochlorate 5 at S.T.P. So to really get this thing done, you need to, let's see how we're going to get a balanced equation of the reaction. The balanced equation of this reaction. From a balanced chemical equation of this reaction, what we will get is that potassium trioxochlorate will decompose to give us chlorine and what? Oxygen. So what we have here will be 2, 2, and then this one will be 3. Now it's balanced. They say that 2 moles from this equation. What we have here is that since 1 mole of every gas, molar volume, which we call molar volume, 1 mole of every gas at S.T.P, or any gas at S.T.P is equal to what? 22.4 dm³. Now we are talking about 2 moles. From this chemical equation, you find out that 2 moles of this will give us 3 moles of the gas. Now, being that we're talking about gases, that means 2 moles of potassium, 2 moles of potassium, or potassium chlorate, trioxochlorate 5 will give us 3 moles of what? Oxygen. 3 moles of oxygen. Now, since the molar volume is 22.4 dm³, what it simply means that the volume that we are looking at, will then be, the volume that's involved here will then be what? 3 times 22.4. That will give us 7.2 dm³. That's what we have. So this is so easy and simple. Just by looking at the chemical equation, it means that 2 moles of this, just take it, let's take it a bit slow. 2 moles of potassium trioxochlorate 5 will give us 3 moles of this. So the volume involved, the reacting volume here, the volume produced will then be moles multiplied by molar volume, which is 22.4 dm³. That will give us what? 67.2. That's what we have here. So the next question, that means this is the correct answer. So the next question we have is say that the volume of gas, what volume of gas is evolved at S.T.P if 2 grams of calcium trioxocarbonate is added to a solution of hydrochloric acid. So let's see what we'll get in this one. We'll also need to write a balanced chemical equation of it. A balanced chemical equation of the decomposition will give us calcium oxide and carbon 4. So in this carbon 4, it means that if you look at this, from this chemical equation, we find out that molar mass of this, or gram times reacting. Reacting gram is what? 100. How do I get this? This is 40, this is 12, carbon is 12, and this other one, 16 times 3 plus 12 plus 40 will get what? 100. So what next are we doing? Then the relationship we're looking from the chemical equation, we're looking at volume of this. We don't have much to do with it because the question said we are going to be doing what? Calculating the volume of this produced. So from here, what we produce here is 1 mole, or then since 1 mole is equal to molar volume, which is molar volume of 22.4 dm cube. That simply means that will give us 22.4 dm cube of what? Carbon 4. So what next are we looking at? What will these 2 grams give us? The 2 grams will then be equivalent to 22.4 over 100 times 2 over 1. So let's see what we will get there. We have 22.4 times 2 divided by 100. So we have 0.448 dm cube. Now, looking at our options, it's like saying that there's something closer to it, which is this one, is in cm cube. So when we multiply, we'll convert to cm cube, which means 0.448 times what? 1000. That will give us 448 cm cube, which is the last answer. You can see how easy this thing is. So one thing about solving chemistry calculation is, in one, you'll be able to write a balanced chemical equation. That's number one. And you'll also be able to extract the information, basic information you have in your word balanced chemical equation. Once you're able to do this thing, you can take the ratio of what we have, because everything I'm doing here just has to do with the ratio. I'm comparing the ratio of the relationship. So that's one of the ways of solving chemistry calculations and make it easier for yourself. Thank you so much for coming this far. I'm so happy to have you here. And if you are joining us for the first time, we'll be happy to just press the subscription button there. And then we'll be so happy to hear from you. If there's anything you want to tell us, anything you want to say about the what we have done so far, leave it in the comment section. And this question also will be in the description of this very video. Thank you so much. Make sure you share, don't forget. Thank you.